So
So
first
you
we
ah,
obtain the sign. So first we obtain the sign magnitude representation of the number, assuming it is positive. Then with
yes.
that assumption, we find the
Here,
binary.
here in this only the here in
Yes,
this
sir.
statement, I want to make a little modification.
Okay, sir.
The first line, please change it for the time being. Uh, Obtain the binary representation of the number, considering that to be unsigned. Obtain the binary representation of the number, considering it to be unsigned. Earlier, I gave the statement. In fact, year after year, I have been giving that same statement that you have to start from the number considering it to be positive, and then you have to go for the sign magnitude representation. Now, in this year, I am changing that first statement, and that first statement now it should be obtain the binary representation of the number considering it to be unsigned. Given that your requirement is to obtain one n bit, one's complement of minus 21. Let n be 6. So what is my first step? I have to consider the given number is just 21. Neither plus 21 nor minus 21. Now I have to find out its unsigned binary representation using 6 bits. What that will be? 16 plus 5. Then 6 bit. So it should be 0 1 0 1 0 1. Hopefully I am correct. Am I correct?
Yes.
Yes, sir.
Yes, sir.
Fine. Now see, if had my original statement was the earlier one, then also you would have got the same thing, isn't it?
Yes.
Yes, sir.
But for the timing, bear with me and change that initial statement to the new statement which I just gave you. Start with with the consideration that the given number is unsigned and obtain its binary representation using the n given bits. Okay, so that's the starting point. Why I am going for this, you'll understand at a later point of time. Maybe in this class, today's class itself. Fine. Now, yesterday, many of you were wanting to go for some examples so that I can establish the one's complement addition scheme to show that this addition scheme, using this addition scheme, I can go for the subtraction. So let us go for this. Let I have several combinations of A and B. And I am going for 6 bit. Six bit one's complement number system I am going for. I've given 6 pairs of A's and B's. You have to go for A plus B operational for each case. Remember here one thing, as the original operands are given in decimal, it is expected that the final result you should also represent in decimal itself. Hope you understand the requirement. The original number pairs of A's and B's are given in decimal. So the final result that should also be, but remember, in between you have to deal with only a 6-bit ones complex number system. But the final result, whatever you are getting in binary, that also should be converted into decimal, so that you can verify yourself whether that plus 21 minus 6 is giving you plus 15 or not. Okay. Anybody having any query? What happened?
No, sir.
Fine. Let's start the process. What is the first step? I described the ones complex addition process in the last class. What is the first step? Yes, Anindita?
Yes, sir. So first normal addition of binary system.
No. The first
First
step
we
is
need to
obtain
convert
the
it
ones
into n
complement
bit
of both
ones
the operands.
complement. Yes, sir. Then addition.
Yeah.
of binary.
So let us go for step by step. So what is your A? The plus 21. So we have to start with plus 21 or something else as per our new convention.
Sir,
To
I'm
We
find
have
saying
to
out.
start with 21 only.
Yeah. So what should be the representative of 21? That is, I think I have already got it. Now check whether the given number is originally positive or not. Is the given number originally positive?
Yes, sir.
So the plus 21 one's complement is the same pattern. Okay. Second one is to find out the one's complement minus 6. So we have to start with 6 only.
6.
So that should be represented in 6 bits. So 0, 0, 0, 1, 1, 0, I think. Now, is that number originally positive?
No, sir.
No, sir.
So minus 6. Okay. So I have now obtained the ones complement of both the operands. So I have to go for the addition. I have to add them using simple binary addition scheme. There is one end around carry. If there is any end around carry, what do I need to do?
Add it
Add
to
it
the
to the least
LSB
bit.
of the result.
Yeah. Now, what is the next step? Remember, if the requirement is to give the answer in binary, that's the result. But as the original operands are given in decimal, so you are required to give the final answer in decimal only. So from there, I have to find out what is the actual decimal result. So what is the next step?
Convert this to decimal.
No.
Sir, if the sign bit of the result
Yeah,
is
next
0,
you have to
then
attack
that
the
is the
sign
answer.
MSB. Next you have to attack the MSB to find out
Yes.
the sign of the result. What is the MSB?
Sir, it's 0.
Zero.
It's 0. So what is the sign?
It's a
Plus.
plus.
Positive.
Positive.
The result is plus, then give the actual magnitude bits. And if the result is positive, what I know that the magnitude is directly given, isn't it? So the magnitude is corresponding to these binary bits. Okay?
So the MSB we considered to be as the sign determinator, right?
Yeah.
So
Yeah.
then again in the result we are again taking the MSB.
Where?
So in the result
No,
we
no,
are assigned the first
no.
zero of the
Yeah,
result is represent
what is the
positive.
final result? What is the final result? Yeah, tell me.
So in binary it came out to be 0041, right?
Yeah, that's all.
And the sir, first zero was representing the positive sign.
But what I told you in the last class, but we are never distinguishing between the sign bit and the magnitude bits while taking any transformation, isn't it?
Okay.
So all the bits are belong to the same category. We will be always assuming that. That's the way 1's complement and 2's complement number systems have been constructed. Okay, because that same mathematics is there, 2 to the power n minus 1 minus of mod x if it is negative.
Yes, sir.
So there you don't find anything related to the sign bit separately. Okay, fine. So this is the way you should do. Remember, these are the steps you have to follow, specifically mention, so that any examiner can understand that you how have you come to the 1's complement of the given operands. Simple, these 4 steps are enough. Okay, now please go for the others. Have I done it correctly?
Yes, sir.
Yes, sir.
Here my suggestion will be you do the sums yourself and please get it verified. Don't just copy whatever I'm doing. That will give you the good practice also. Okay, fine. So is there any end around carry?
No, sir.
No,
So
sir.
nothing needs to be added, isn't it? Nothing needs to be added at the least 7-bit position as there is no end around carry. So this is the final result. So what I have to do?
So
I have
one
to
is
take,
there, so a negative sign will be
I
there,
have to
and
take,
when then
I have
take
to
the
check for
complement.
the sign bit. There's the MSB. So MSB is 1. So the result is negative. So what I will write is result is equal to minus of, and as the result is negative, I know that the magnitude is not directly available. I have to go for its 1's complement, that means bit by bit complementation, to find out the magnitude. And that bit by bit complementation gives me 0, 0, 1, 1, 1, 1 in binary. So that is nothing but minus of it. Okay?
Yes, sir.
Fine. I'm going for the last one.
Sir, can you get back to the previous slide once?
You sure?
Thank you, sir.
Himanshu Ranjan, what is the scheduled time for the class? Himanshu Ranjan.
Sorry, sir. Actually, I was a bit outside, so that's why.
Yeah, this was the result for plus 6 and plus 12. Now I am going for minus 6 plus of minus 12. So as the 6 and 12 are already available, so I can straight away go for the 1's complement of minus 6 and minus 12. And I have added them using the binary addition rule. Now after addition, there is there any enter on carry?
Yes, sir.
So I have to add it with the least in the position of the result. Now check the sign bit of the result. What is the sign?
Negative.
Negative, sir.
So result is minus, and to find out the magnitude, you have to take it to
1's complement.
Okay. Normally, in most of the books, what we will be finding is the as the 1's complement addition rule. What they are suggesting after up to the addition process, the things are same as per what I have given. But after that, there is a difference. In most 99.99% books, what you will find is they are saying that if there is any end error on carry, you have to add it to the list in a bit portion of the result. That's fine. And at the same time, they are saying that the result is positive. If there is an end error on carry, the result is positive, and you have to add the end error on carry with the list in bit portion of the result. And in case there is no end error on carry, they are claiming that the result is negative. In almost every book, you will find that logic.
And sir, if means in case of 0, if the answer comes out to be negative, then we need to once complement the result to get the actual result.
In case of 0 means?
Means sir, here the carry is 1, so we need to just add it to the result to get
Yeah,
the
yeah,
actual. So
yeah.
in case of 1, if it is 0, so then we should take the ones complement of it at the number is negative.
You give. I'm not getting your point once again. Please, bear with me.
Sir, if the most significant bit is 0, means here it is 1, but if it was 0, so then carry won't come 0. Why?
Hello? Your voice.
So sir, if the most significant bit is 0, then as you said, the result is negative, so we need to just one complement this result to get the actual result. Means that this was written in the books, so that's why I'm telling that. Is it so?
One phone call came and I got disconnected. Please repeat. Can you hear me?
Yes, sir. Yes, sir.
Huh.
Sir,
Please.
in one of the book it is written that if the final carry is 1, then add it to the result obtained in the means actual result
Hmm.
that we did. But
Hmm.
if the carry is 0, then
Hmm.
result obtained is
Hmm.
negative, and in this case we need to
That's
just
what
one
I'm
complement.
telling you. That's what I'm telling you. Now, this process is totally wrong process, as evident from this one. Is there any end around carry?
No, sir.
So is the result negative?
No, sir.
So
So I
this
have a
way.
doubt.
Udvas.
So if the addition is like one, that means 7 times 1. Then the final carry will go at the LSB. And hello, sir.
No, if there is a whenever there is any end around carry, that has to be added with the least in a bit position.
So I'm saying that the Indian carry is 1, and the rest of the bits are also 1. Then it will.
You give one. You come out with one such example. You
So
come
for
out
the
with one
final
such
answer
example.
is 7 1s, sir.
You can never find that example. Until unless you go for all negative numbers. Nila Pro or what is it? I do not know.
Yes, sir. Nilardo, sir. Yes.
বলো কি বলছিলে?
So, sir, what should we do in that case? Means, as you said, it is wrong. So, sir.
What you should do is you should reject all those books and you have to follow what I am telling you. I have been teaching this
Okay, sir.
for last 33 years, and
No, no, sir. I'm
all
not.
my
I'm not
students.
saying that. I'm not saying that.
No,
I'm just asking, sir.
yeah,
What
that's
should
why
I do?
none of my students consult any book, any teacher electronics book. They only consult the books for solving problems. That's all. For the theory part, none of my students need to consult any book ever.
Okay, sir. I will do the same, sir.
Okay, so
Yes.
in fact that's why I at the very beginning also told you that whatever you have learned in the past two courses, or somebody who will later join as lateral entry students, uh, whatever they have learned in polytechnics, they should all erase whatever they have learned, and all of you must start afresh. Okay, fine.
Sir,
Huh.
sir,
So can
if
you
hello, sir.
Hello?
So if the addition is 1 and 5 times 0 and 1, it is possible?
You give me the example of the operands. I'll do it. You give my operands.
Okay, sir, I actually have some.
You give me the value of A and the value of B corresponding.
No,
I'll
sir,
do
it
it.
is still actually, sir. So I have got it.
Okay, fine. Now go for the rest of the tools.
sir for -21 and -12 I am having some problem. Can you please show it?
What problem you are having? Let me see.
-21 and
You
-12.
please dictate me. 21. Tell me.
Sir 21 is 0 1 0 1 0 1.
Ah, tell
Minus
me.
21 is 1 0
No,
1 0 1 0.
I have forgot to write this one.
Yes, sir. One stop. 0 0. Then -12 is 1's complement. 1 1 0 0 1 1. 1 1 0 1. Yes. 0 1 1 1.
So what is the result?
So 0 4 1s and 0.
No. First of all, I have to target.
सर
First of all,
पॉजिटिव
I
की
have to
कौन
target.
So it a positive चला है.
है
ये
सर
वाला.
Don't be. Just follow whatever statement I have given. First of all, I have to target. I have to check for
Sir sign.
sign.
MF
What is the sign bit? 0 or 1?
is 0.
So result is positive. And the magnitude is directly obtained. What is the magnitude?
0 0.
30.
Oh, sorry.
It's
So I
coming
should
30.
no, I should write the binary pattern first. Then in the next step, so adding two negative numbers, you are getting a positive quantity.
Yes, sir.
So there you must doubt. You should doubt my process, and that should be there. The doubt should be in your mind. Now let us go for the other one. What is the other one? What is the last combination of A and B?
Sir, plus 6 and plus 12. It was done.
12 and plus 21, isn't it? So that is plus 21, one's complement is that same 0, 1, 0, 1, 0, 1, and plus 12, one's complement is the same unsigned pattern, that is 0, 0, 1, 1, 0.
Plus 11. It
Oh,
was
11. Oh, sorry. So, no problem.
Sir, it was 12 only, sir.
11 plus
12.
21 plus 1.
Oh,
Oh, 11.
11, 11.
কোথায় গেল? So this I can state right. What that will be 1011, isn't it? The unsigned pattern for 11 is 001011. So 1's complement of plus 11 is also the same thing, 001011. So let me go for that addition. Okay. So what is the next step?
Check the sign bit.
What is the sign bit?
One.
So the result is negative. And can you find the magnitude directly?
No, sir.
No,
Complement.
sir. 1's complement.
That is how much? In decimal?
51.
31, sir.
31.
So here also we find that by adding two positive numbers, I am getting a negative number. So does it mean that my process fails for two positive numbers and two negative numbers? Does it mean that?
No, sir.
Because I have already found some examples where by adding two positive numbers I am getting the required result, and while adding the two negative numbers I have got the required result. Probably
So the last one,
Yes.
612.
probably here, isn't it? But here my process fails. By adding two negative numbers, I am getting a positive number. Well, by adding two positive numbers, I am getting a negative number.
So the range of the result is beyond the representation.
What do you mean by the range of the number? Have,
So
have
like,
you have you talked about any such range here in this class?
no, sir.
Say I have a 3-bit number system. How many binary combinations will be there?
8.
These are the 8 possible combinations. This binary pattern or this 3-bit number system, if it belongs to unsigned number system, what are the decimal numbers that are corresponding to these binary patterns? If this number system, if this 3-bit trivial number system corresponds to one unsigned number system, what are the corresponding decimal numbers for each of the binary combinations?
0 to
7.
7.
1, 2, 3, 4, 5, 7, 8, 7 up to 7.
Sign magnitude. What is the 000 correspond to? This 3-bit
The 0.
no,
Zero.
no, no,
Plus
no.
0.
Plus 0. First, as you are told that this binary pattern is corresponding to one decimal number in sign magnitude number system. So sign magnitude number system comes under the sign number system category. So in the sign number system category, always the MSB will represent the sign bit. So first we'll target the MSB. As the MSB is 0, I'll simply write it positive. And the same is here, the 4 are negative. So as it is sign magnitude number system, we know that apart from the sign bit, the other bits will represent the magnitude directly. Okay, so the magnitude is 0, then 1, then 2, then 3. So plus 0, plus 1, plus 2, plus 3. Then, as the number is negative, I know that the magnitude cannot be directly obtained. To find out the magnitude, what I have to do?
Complement 1's.
I take the bit by bit complementation of the whole pattern. Remember, I am not going for the bit by bit complementation for the magnitude of bits only. I am going for the bit by bit complementation of the complete pattern, and the bit by bit complementation gives 0. So that 0, 1, 1 corresponds to the magnitude. Sorry,
minus 3.
yeah, 3. Then
minus
0,
2.
1, 0, 2. Then
Minus 1.
0, 1. Then
Minus 0.
0, 0, 0. That is minus 0. Okay.
So
Fine.
this is the case with 1's complement and 2's complement, right? So why are we doing this with sign?
I don't know. I have not yet studied what happens to 1's complement, what happens to 2's complement. I have not yet studied what the 2's complement number system is. That also I have not studied.
So, but in sign magnitude, the first bit would represent the sign and the next bit would represent the magnitude directly, na sir?
The other, if it is the positive number, if it is negative number, oh, sorry. Yeah, you are right. You are absolutely right. Thank you. What I have told you, that is for the 1's complement. You are absolutely right. Thank you. This is sign magnitude representation. So the first bit will be the sign bit, and the other bits apart from the sign bit are the magnitude bits directly. So that is minus
0.
minus 0. Then
1 minus 1 minus 2
minus 2
minus 3.
minus 3. Thank you. Thank you, Nilato. Then you go for the 1's complement. For the 1's complement, we know that for positive number, the sign magnitude and the 1's complement both will be the same. Because it will start with the positive sign, that is 0, and the other bits will be only the magnitude bits. So these are plus 0, plus 1, plus 2, and plus 3. Now these 4 have to be negative. Now, as it is negative, I know that the magnitude cannot be directly obtained unless I go for bit by bit complementation of the complete pattern. So the bit by bit complementation of the complete pattern gives me it is the magnitude for magnitude, it is 0, 1, 1. That is nothing but
minus 3 minus 2 minus 1 minus.
fine. Now let me go back to the binary patterns. How many distinct binary patterns are there? How many distinct binary patterns are there?
Eight.
4.
8. There in B2, B1, B0, how many distinct binary patterns are there? There are obviously 8 distinct binary patterns. So using these 8 distinct binary patterns, how many decimal numbers can you represent in unsigned form?
8.
8.
8. So all the binary patterns are utilized to represent one unique decimal number. For sign magnitude, how many distinct decimal numbers can you represent?
4. 8.
Really?
7.
Yeah. There are 7. What is the minimum one?
-3.
Zero.
Minus 3. Minus 3 is the minimum one. And what is the maximum one?
+3.
So minus 3 to plus 3 is nothing but 7 distinct combinations. So using 8 distinct binary patterns, how many distinct decimal numbers you can represent? In sign manager? 7. One. Definitely in that case you are wasting one binary pattern somewhere. Where is that wastage?
The
Zero.
+0 and -0.
Yeah. That plus 0 minus 0 has got no mathematical significance. 0 is 0. There is no significance of plus 0 or minus 0. But the way sign and number system has been constructed, we have to consider that okay, there is no way we have to waste one binary pattern for representing plus 0 and minus. Though it has got no mathematical significance. What about for the ones complement? It is the same thing. It is the same thing. There is once again one wastage of binary pattern to represent plus 0 as well as minus 0. Now given instead of 3, if I have one n-bit number system, what is the range of numbers that you can represent in unsigned? That is 0 to
2 to the power n.
no.
2 to the power n minus 2 to the power n minus 1.
What about for the sign magnitude? First give me the lower end, lower limit. Minus of
So 2 to the power of n minus
2 to the power n minus 1.
n minus 1
Minus
minus
1.
1 plus of same is true for the ones complement also. Okay. So now in our example, okay, here, sorry, here. What is the value of n?
6.
6.
So what is the type of number system you are considering?
1's complement.
Ones complement. So in that ones complement 6-bit number system, what is the range of numbers that you can represent?
2 to the power
Minus
minus
31 to plus 31.
Minus 1 minus 2 plus of that. So that means how much?
Minus
So
31 to plus 31.
Minus
31 to plus 31. That is the range of numbers that can be accommodated within this 6-bit ones complement number system. Now, when you are going for this addition, what is the required result?
Minus 33.
See, can it be accommodated by this 6-bit ones complement number system?
No.
No.
Yeah.
What about here?
32.
Plus
Plus 32. Plus 32. Once again, that can also not be accommodated within this 6-bit ones complement number system. Either consider one real life example. Say you have a can of 1 liter. If you want to store 2 liters of oil in it, what will happen?
It will overflow.
It will overflow. The same thing happens here. The number system has the capacity to store minus 31 to plus 31. But you are trying to store something more than that capacity. So what will happen? There will overflow. See, here, there is absolutely no problem. Why? What is the required result?
Minus 18.
That's 18. That is well within your range. Is it not?
Yes, sir.
Yes.
Yes, sir.
Now, tell me one thing. In case one operand, if the operands are of opposite sign, can there be any overflow? Is there any possibility of overflow? If the operands are of opposite sign, is there any possibility of overflow?
No, sir.
No, sir.
No, sir.
Why?
No, sir.
Why?
So, sir, let's say minus 31 plus 0 or means plus 1 or plus 0 will
No,
be
no.
within range.
Basically, there what you are doing. If both the operands are opposite, if the operands are of opposite side, then you are basically going
Subtraction
for
is
subtraction operation. So if you go for the subtraction operation, in that case the result will be definitely magnitude wise. I'm talking about the magnitude wise. The result will be less than the operand which is having the larger magnitude. Is it not?
Yes,
The
sir.
result magnitude. I'm talking about the magnitude wise, not with sign. The magnitude wise, the result will be definitely less than the largest magnitude of the operand which is having the largest magnitude. Okay, so definitely there is no question of any overflow, and definitely I am assuming that the operands are already well defined within that given number system. The operands are not going beyond that number system capacity. Definitely, we are assuming that. Now, in case you are going for addition of operands where both the operands are of same sign, then there is a chance of overflow. But I am not saying there will be overflow. What I am claiming is there will be a chance of overflow in case both the operands are of same sign. Why? Because there the result magnitude will be definitely more than the magnitude of the operand which is having the larger magnitude. Is it not? The result will be definitely more than both the operands. If you go for addition of two operands which are of same sign. See, here I have added two positive numbers. Here I have added two negative numbers. But there you have not encountered the overflow. But here in these two cases you have encountered overflow. So that's why I am saying that in case both the operands are of same sign, there is a chance of overflow. But there is no guarantee that always there will be overflow. There may or may not be overflow. Now, how will you find out whether there is an overflow or not? How will you find out whether there is an overflow or not? What is the indicator that the operation has resulted into one overflow? Any idea? We've already seen that. Nobody.
Sir, the sign is different from both the operand sign.
Here, by adding two negative numbers, you obtain one positive answer, positive result. That gives you the indication that overflow has occurred. Similarly, by adding two positive numbers, if you get one negative answer, that will also give you the indication of overflow. So how to check whether the overflow has occurred or not? First of all, if the operands are of opposite sign, there is no chance of overflow. First of all, if the operands are of opposite sign, there is no chance of overflow. Overflow may occur in case of the operands are of of same sign. Now, how do you find out whether overflow has occurred? Now, by adding two positive numbers, if the result obtained is negative, or by adding two negative numbers, if the result obtained is positive, we will infer that overflow has occurred. And if overflow occurs, what can you do? দু লিটার অয়েল পোর করতে গিয়ে যদি ওভারফ্লো করে, what can you do?
So increase the size of the container.
Yeah, you cannot do anything with that same bottle unless you are provided with a bottle of a larger capacity. So in same thing happens here, is true here also. In case overflow occurs, you cannot do anything unless you go for a larger a number system having larger number of bits. Instead of 6 bit, if you go for 7-bit number system, definitely this plus 30 and minus 31, plus 33, sorry, minus 33 and plus 32 can be accommodated. Okay, but definitely there will also be, you will find the overflow at some point of time, because whatever is the number system bit capacity, that is limited by certain range. If the required result goes beyond that range, there will be overflow. So only one thing what you can do is, if overflow occurs, you have to detect that overflow and raise one overflow flag. That flag will indicate that during the arithmetic operation some overflow has occurred. So in every microcontroller or microprocessor, there will be one particular flag called overflow flag. That overflow, by checking that overflow flag, that means if that overflow flag is 0, that means that indicates that the arithmetic operation has not yielded any overflow. But if that overflow flag becomes 1, that gives the indication to the user that during the arithmetic operation certain malfunction occurred due to the limited capacity of the number system, and that malfunction is nothing but your overflow operation. Okay, so hope this overflow concept is clear.
So when we increase the bits, we increase the bits of both the operands and the results, right?
Yeah, definitely.
So the possibility of overflow, like it always exists. It can never go away.
Yeah, that's why just now I told you, na? Even if we increase the number of bits, at certain point of time, once again overflow will come into picture.
Okay, sir. Okay.
So in no way you can totally eliminate overflow. If you have to totally eliminate overflow, you have to go for a number system having infinite number of bit capacity. That is not feasible. That is not feasible. So every processor, either that may be 64-bit or 32-bit or 16-bit, whatever it is, definitely there will be certain limitation. Okay, so infinite capacity no longer exists. Fine. So hope that's all from the 1's complement number system context. Now we'll go for the 2's complement number system. What are the process that we discuss for 2's complement number system?
So 2 to the power of n minus mod x.
No, that's the arithmetic operation. find out the 2's complement of any number, you have to first find out its 1's complement, and then you have to add 1 with it. I think that was the rule. And this rule is given in every book, I think. Is it not? Once again, here my rule will be a little bit different. Once again, the starting point will be consider the number is unsigned and find out its binary representation. Assuming the given number is unsigned, find its binary representation. Considering the number to be unsigned, find out its binary representation. Now, if the number is originally positive, this is the 2's complement representation. If the number is originally positive, this is the 2's complement representation. However, if the number is negative, আমায় কি করতে হবে?
2's complement নিতে হবে।
হ্যাঁ, 2's complement নিতে হবে, তাই জন্য কি করতে হবে?
1's complement নিয়ে অ্যাড করতে হবে।
ফাইন, একটা এক্সাম্পলে যাই, সে -12 6 bit 2's complement. So what is the starting point? 12 unsigned ধরে নিয়ে 0 6 bit 001100. So -12 তার ফার্স্ট কি বের করব?
1's complement.
1's complement. So what will be that? 110011. Now -12, its 2's complement will be
+1.
I have to add 1. So 0 0 1 0 1 1. So that's the 2's complement of -12. So basically, this is a two-step process. Well, in the first step, I have to find out its 1's complement, and then I have to go for one arithmetic addition operation of adding 1 with the 1's complement. Isn't it? This is basically one two-step process. One is whatever the starting point is a binary representation of the unsigned pattern. Binary representation of the unsigned number. That's the starting point. From that starting point, first I have to find out the 1's complement, and then I have to add 1 with it. This is the process you will find in almost every book. আমি একটা জিনিস বলছি, to find out the 1's complement, how many steps are there? Remember, I am not considering obtaining the sign, that unsigned binary pattern to be one step. That's the starting point. With the starting point, how many steps are there to find out the 1's complement? Starting from the unsigned binary pattern of the given number, considering that to be unsigned, how many steps are there to find out the 1's complement?
The 2 steps.
One only, sir.
Only one step. As it is negative, so you have to take bit by bit complement. That's all. Just by observation, I can tell you what should be the 1's complement of that -12. But to find out the 2's complement, just by observation till this point, I cannot tell it. I have to go via 1's complement. That 1's complement was readily available just by observation. But with that, I have to go for one arithmetic addition operation. So this is the process you will find in most of the books. Now I will deviate from here. My কোন পর্যন্ত বলা হয়েছে তোমার প্রসেসটা? You obtained the binary pattern for the unsigned, considering the number to be unsigned. Then if the number is originally positive, that is the 2's complement representation. So up to this point, there is no problem. Now I will deviate from the usual process. Now my process is, if the number is originally negative, scan the unsigned binary pattern starting from the least significant bit. Scan the unsigned binary pattern starting from the least significant bit. What is the unsigned binary pattern? The number is originally negative. So I have to start scanning the pattern starting from which bit? This bit. Now what we will be doing? Scanning means just you are observing. Scan the pattern starting from the least significant bit. Now copy up to first one. First one, when you are getting the first one? At this point, isn't it? You are scanning starting from the least significant bit, where you are getting the first one at this point. So you have to copy up to that. Then complement all other bits.
Sir, please repeat once again, sir.
Considering the given number to be unsigned, find out its binary representation. If the number is originally positive, that is the 2's complement representation. If the number is originally negative, scan the binary representation starting from the least significant bit. Copy up to first one. প্রথম 1 পর্যন্ত কপি করো। Then complement all other bits. Then onwards, whatever bits are coming, you just go for bit by bit complementation.
Okay, sir.
Let me go for another example. Minus 22, 176 bit. So let us follow the usual process first. So plus 22, its unsigned representation will be how much? 16 plus 4 plus 2. Isn't it? Yeah. Then minus 22, 1's complement. Then minus 22, 2's complement. This is the usual process that is followed in books. Then 0, 1, 0, 1. Okay? And if you follow my process, scan this pattern starting from the least significant bit. Copy up to first one, that means 1, 0. Then complement all of it. 0, 1, 0, 1. Then. Okay?
Yes, sir. Yes.
In fact, in many books, you will find this process also. This is not very uncommon. But most of the places, they follow this one. But this process is also very quite common one. What I have just now told you. That scan the pattern starting from the listing bit, copy up to first one, then complement all of the bits. Okay. So, but I expect you to follow this process only. Don't waste time for going via the 1's complement. Okay.
So what if the least significant bit is 1? So do we complement the entire thing?
No.
First one will be copied.
Let us have one example, say minus 11. So 11, its unsigned pattern is 0, 0, 8, then 3. Isn't it? Copy up to first one. 1. Then complement all other bits. So
Okay,
this is the 2's complement of minus 11. Okay. You have to copy up to wherever you find the first one, you have to copy up to that point. And rest bit onwards, you have to complement. Hope the process to find the 2's complement of any number is clear.
Yes, sir.
Fine. I am going for once again generalized x plus y operation. Let x is equal to positive, and this is not j, this is semicolon, and y is equal to negative. So what is the required result? Required result must be plus of mod x minus of mod y. Is it not? That should be the required result. Now, for any negative number, the 2's complement of any negative number, arithmetically how that negative number is 2's complement is obtained. Now, how the 1's complement of a negative number is obtained? Now, 2 to the power n minus 1 minus of mod y, as y is the negative quantity here. Isn't it? That's the 1's complement. How the 2's complement mathematically obtained? You have to add 1 with it. Is it not?
Yes, sir.
So if you add 1 with it, then this plus 1 and this minus 1 gets cancelled out, and what is left is 2 to the power n of n minus of mod y. So now this x plus y, where x is positive and y is negative, is nothing but plus of mod x plus of 2 to the power n minus of mod y. So that is nothing but 2 to the power n plus of mod x minus of mod y. Is it clear?
Yes, sir.
Now, there will be three cases. There will be three cases. One is magnitude wise both are same. In that case, this is how much?
0.
0.
So, what is the result you are getting? 2 to the power n. So, what is the 2 to the power n? This is your NB pattern. What is 2 to the power n? We have seen it in the last class also.
So the final carry.
Yeah. This is one carry in the n plus 1 at bit position. Okay, so this 2 to the power n is nothing but the final carry or the end around carry. Now, what is the required result in this particular situation?
So 2 to the power of n.
No, no. What is the required result? Required result. When mod of x and magnitude of x and y are same. শুনতে পাইনি বাবা আর বলো
0.
0. It's 0. So how do you get 0 result? If you ignore this end around carry or the final carry.
Yes, sir.
Simply ignore this end around carry or the final carry, you will be getting the result. You will be getting the required result. Okay? Fine. So that means in case x and y are magnitude same, in that case I'll simply ignore this 2 to the power n, that is nothing but the end around carry or the final carry to get the result 0. Fine. The next option.
Sir, please move back to the previous slide once again, sir.
Yeah.
Okay, sir, now proceed.
Next option I am going for is greater than mod of x is greater than mod of y. Okay, by the way, that x plus of y is 2 to the power n minus of no plus of এটি ছিল নাকি ভুলে গেছি আমি
হ্যাঁ স্যার
correct. So in case magnitude of x is more than magnitude of y, what will happen? This quantity, what can you say about this quantity?
Greater than 0.
Is greater than 0. So that means this 2 to the power n is nothing but one end around carry, and this x minus y is confined within this n bits. Now, how can you achieve that required result of mod x minus mod y?
So we ignore the final carry.
Ignore the final carry or the end around carry. Simply ignore it. Okay. Remember, in the case of 1's complement addition operation, whenever we were encountering any end around carry or the final carry, we needed to add it with the least bit equation of the result. But here we have to simply ignore that. Now the final thing. So x plus y is equal to 2 to the power n which can be written as in case mod x is less than mod y, what is your required result? Now minus of mod y minus mod x, isn't it? In case mod x is less than mod y, what is the required result? Remember, you are going for x plus y operation, where x is positive and y is negative. Say, for example, x is plus 5, y is minus 12. So what is the required result? What is
Minus
the
7.
Minus 7.
minus of 7? How do you get that? Nothing but by this. Is it not?
Yes, sir.
So now, in case this is the situation, what is the required result? Now minus of mod y minus mod x. Is it positive or negative?
Negative, sir.
Negative. Now for this negative quantity, what is the 2's complement representation? For minus of mod y, what is the 2's complement representation?
So 2 to the power of
2
n
to the
minus
power
y.
n minus y.
Minus of mod y. So what will be the 2's complement representation of minus of this?
2 to the power n minus that quantity.
That already you have obtained. Is it not? That quantity already you have obtained.
Yes, sir.
So here the 2's complement addition process is obtain the 2's complement of both the operands, add them using binary addition scheme. If there is any end around carry, simply ignore it. If there is any end around carry, simply ignore it. Now check the sign bit of the result. Now check the sign bit of the result. If it is 0, the result is positive and the magnitude can be directly obtained. If it is 0, the result is positive and the magnitude can be directly obtained. However, if it is 1, the result is negative, and to find out the magnitude, you have to take its 2's complement again. However, if it is 1, the result is negative, and to find out the magnitude, you have to take its 2's complement again. Is the process clear?
Sir, can you repeat it once?
Yeah. Find out the 2's complement of both the operands. Add them using binary addition scheme or rule, whatever you say. If there is any end around carry, simply ignore it. Now check the result. Now check the sign bit of the result. Now check the sign bit of the result. If it is 0, sign bit means most significant bit, I am referring to that. If it is 0, the result is positive and the magnitude can be directly obtained. If it is 0, the result is positive and the magnitude can be directly obtained. However, if it is 1, the result is negative to find out the magnitude, we have to take its 2's complement again. Clear?
Yes, sir.
We'll do several examples. We'll go for that. No problem. Before going for that, I'll come back to this one. Now let us fill up the corresponding decimal numbers for the 2's complement notation. 2's complement number system. For 000, what will be the decimal number?
Plus 0 only.
Then
Plus 1.
remember, for positive numbers, the sign magnitude, 1's complement, 2's complement, all three will be same. For positive numbers, the pattern for sign magnitude, 1's complement, 2's complement, all three are same. It is only for the negative numbers where we have to go for the transformations. Now 100. What is the sign?
Minus.
Minus.
As it is a negative number, so to find out the magnitude, what you need to do?
2's complement.
Take its 2's complement. What is the process for the 2's complement?
Copy up to
Copy
1.
the first one. No, where the first one is coming here?
MSB.
At the MSB itself. So the magnitude is 100 itself. So how much is that?
-4.
4, sir.
Magnitude is 4, the number is -4. Fine. Then it is negative number. To find out the 2's complement, we have to copy of the first one. First one
-1.
here. Then 1, 0. So minus 3. Okay.
Yes, sir.
Then 1, 1, 0. How much this will be?
0,
-2.
0, 1.
No. 0, 1, 0.
Sorry, 0, 1, 0,
-2.
0, 1, 0.
Minus 2. Then
-1.
Minus
minus
1.
0, 0, 1. Okay. So how many distinct decimal numbers you are able to represent here?
8, sir.
8, sir.
8. Is there any wastage?
No, sir.
No. So that's the best thing of the 2's complement number system. Remember, using this sign managed number system definitely helps us in realizing two different categories of numbers, positive and negative. But it does not help us in realizing subtraction operation using addition scale. Is it not?
Yes, sir.
But the 1's complement number system that does help us in realizing subtraction operation using addition scheme. True or false?
True, sir.
True. So, but then why are we going for the 2's complement number system at all? Because my 1's complement number system helps me to realize that requirement. But still, we do prefer 2's complement number system. Why? There is no wastage of any binary pattern. There is no wastage of any binary pattern. And what is the range of numbers that can be represented?
Minus 2 to the power n minus 1, 2 plus 2 to the power n minus 1 minus 1.
Okay. So in the negative side, there is one more number that I can represent here. In fact, I suggest you to remember these ranges involving n, the general ranges for unsigned, signed, magnitude, 1's complement, 2's complement. In many competitive examinations and in GATE also, these may be of help sometime. So please try to remember these ranges. Let's go for this these 5 combinations. So starting point to find out the 2's complement of minus 21 is assume that to be unsigned. By the way, 6 bit. 6-bit 2's complement number system. 21 means your 16 plus 16 plus 4 this minus 21 2's complement. Copy up to first one, then complement all other bits. 6 0 0 0 1 1 0. There is no end around carry, so nothing needs to be ignored. Now the final step is I have to check for the sign bit of the result. What is the sign bit?
1, so it is negative number.
1. So this is negative. So the result I have to write like this, minus. I have to find out the magnitude, I have to take its 2's complement again. So that means copy of the first one, then complement all other bits. It is minus 15, I think. Okay. Then plus 21 minus 6. Plus 21 is 0, 1, 0, 1, 0, 1. Minus 6 will be copy of the first one, then complement all other bits. I'm skipping steps. But
Yes,
in
sir, no
exam, you don't
problem.
skip the steps. Okay. So if I go for the addition, it becomes 1, 1, 1, 1, 0, 0, 1. This is the end around carry of the final carry. So what I have to do?
Ignore.
So the result is this. So here I have to check for the sign bit first. What is that? 0. So the result is positive and the magnitude is directly obtained. Okay. Any doubt till this point? Any doubt till this point?
No, sir.
Yes, sir.
Okay, plus 21 plus 6 plus 21 2's complement is how much? Please tell me. 0, 1, 0, 1, 0, 1. Isn't it? Is it plus 21? 2's complement?
Yes, sir.
Yes.
And plus 6 2's complement. No end around carries, nothing needs to be ignored. So this is the final result, and the final result is positive, and it is result is equal to plus of 0, 1, 1, 0, 1, 1. So that is how much? Plus of this will be 31 minus
27.
27. Okay.
Yes, sir.
So now what is left? Minus 21 minus 11. Minus 21. What is that 2's complement? Copy of the first one. This is minus 21. Minus 11. 11 is 0, 0, 1, 0, 1, 1. Minus 11 is then 1, 0, 1, 0, 1, 1. 2's complement. Both are. Hope I have done it correctly. Please verify. Are they okay?
Yes, sir.
Fine. 0. There is one end around carry. What I have to do with this end around carry?
Ignore.
Ignore. So what is the result?
Minus of
No, sir. We have to take
Two
complement.
complement, yes, the
Two's
first
complement.
one is coming at the MSB itself. So the same complete pattern will be there in the two's magnitude. So what will it be? Minus of how much is it?
32.
32. So that's the
Say
required
in
result.
the say in the MSB it is 1, sir. We should
Yep,
take
that's it.
complement. Okay, sir. Okay, sir.
You have to, so this as the MSB is 1, the result is negative. So you cannot get the magnitude directly. So to find out the magnitude, what you need to do? You take it to 2's complement again. So what is the process of 2's complementation? You have to copy up the first one, then complement all the bits. Now the first one itself is coming in the MSB position itself. So you have to copy all the bits. That's right. Okay. So the result becomes minus 32. That's the required result. And finally, plus 21 and plus 11. Plus 21 is 0, 1, 0, 1, 0, 1. Plus 11 is 0, 0, 1, 0, 1, 1. Is it not?
Yes, sir.
So this is 0, 0, 0, 0, 0, 1. Is there any end around carry?
No, sir.
So what should be the result?
Yes.
Shouldn't be
2's complement of this, the minus is 2.
Sir, minus of this 2's complement.
To choose complement is same thing.
Ah.
How much?
Sir, 32. Minus 32. Minus 32.
Is it the required result?
No, sir.
What has happened here?
Say it exceeded the
Sign
bound.
overflow. Range
What?
variation.
Overflow has occurred.
Overflow.
Why overflow has occurred for plus 21 plus 11 but not for minus 21 minus 11? Why?
Sir, because
The
the
range was
Yeah, range is more in the negative side.
negative side.
Yeah, as it is a 6-bit number system, the range is minus 32 to plus 31. So this minus 32 required result is well within my capacity. But here my required result is plus 32, which is going beyond my capacity. So that's the reason for the overflow. And what is the indication of overflow? Once again, by adding two positive numbers, I have obtained a negative result. Similarly, it may so happen that by adding two negative numbers, you may get one positive result. That is also the case of one overflow. So once again, just like your 1's complement addition scheme, here also, in case the operands are of opposite sign, there is never any chance of overflow. If the operands are of opposite sign, there is never any chance of occurrence of overflow. But if the operands are of same sign, then there may be overflow. May not be also. But how will you find out overflow has occurred? Now, but we'll check the sign bit of the operands. We'll check the sign bit of the result. If the operands are of same sign, then only we'll go for checking the overflow. Otherwise, I can straight away say that the overflow flag is 0. But if the operands are of same sign, both 0 or both 1, but in the both 0 case, if the result is 1, I'll have to raise overflow flag to be 1. If both the operands are having the MSB 1, that is the sign bit 1, but the result is having the sign bit 0, in that case also I have to raise the overflow flag. You got the point? the logic for generating the overflow flag?
Yes, sir.
And due to that, as the range of 2's complement number system is more than that of 1's complement number system, and that means as in the 2's complement number system there is no bit pattern wasted. That's why it is the 2's complement number system that is all over used in digital systems. Be it one microprocessor, be it one microcontroller, or any power processor, whatever it is, for every arithmetic operation, we take help of 2's complement number system. Okay? Is anybody having any doubt till this point?
No, sir.
Fine. The thing is, today I'll stop here because the next topic which I start may not be over within 15 minutes. So I'll stop it here now. By the way, but Arnav, one thing I want to tell you that many of you are not giving your response in attendance, during attendance. So they are being marked absent.
Okay,
So
sir.
please ask everybody present in the class to be present physically. I know that many of you are just joining the class and going somewhere else. That I know. That's the usual trend, I know. But that is not a good sign also. Anyway, it's up to you. But ask them to give the attendance in the chat box. Only after you give the attendance in the chat box, that will be recorded, nothing else. Okay, now you may give your attendance and email it.